So first one, when the car is moving forward, you know that it has a velocity, which is a speed, and acceleration, which is how the velocity changes. When you're given a distance, which is s, if you drive that distance value over a time, it's going to be a velocity. If you drive a velocity over the time, that's going to be an acceleration. Second one, if you look closely at the wheels, they will have a angular velocity, which is how fast the wheel moves. Angular velocity is equal to velocity over radius, and then the angular acceleration, which is a derivative of angular velocity. So how fast the angular velocity changes. There are two types of acceleration, which is tangential acceleration, which moves along the movement, and normal acceleration, which is an acceleration that points towards the middle of the radius. These are the formulas for each. Relative motions. So there's car A and car B moving forward at a different speed. Relative velocity of these would be VA minus VB. So this talks about how fast the car A moves if you look at it while you're sitting at car B. And given the velocity of these two, we can just subtract these two and get the value of negative 9 meters per second, which means that if you look at the car A from while sitting at car B, it seems like car A is moving 9 meters per second backward, although in reality, they are moving forward 1 meters per second. Another concept is instant center. So you have two different objects tied by the wood. As the system rotates and pushes this to the left, the rectangle is also going to move leftward, demonstrated by velocity of A. And instantaneous center is a point perpendicular to both of these movements, and it is a point in a body where it is not moving, so the velocity is equal to 0. This rigid body system, it is rotating about instantaneous center. Another interesting topic, it is force and acceleration concept. So as you know, force is just force that moves the car forward. Acceleration is how fast the speed of the car changes. F is equal to ma. So if the object is very heavy and they move forward very quickly, you know that the force is going to be very strong, demonstrated by this formula, F is equal to ma. Moment is another concept that is covered in this course. Moment is equal to force times radius. If you have a door and a hinge, to make it easier to open the door, it is important that you grab a far side from a hinge, because according to this moment formula, as the radius increases, the moment will also increase, which means that pushing down a far side of the hinge is going to be more effective than pushing down a closed side of the hinge to open the door. And force is how hard you push the door, so as the force increases, it is more likely that you're gonna open the door. Another formula for moment that is used frequently, it is moment is equal to I times angular acceleration, so I being a moment of inertia that resists the spinning. The frictional force is also an interesting topic. So as the wheels try to rotate, they try to push the ground backward, whereas the ground tries to push the wheel forward. And that is a frictional force that is being demonstrated here. As the car moves forward, the frictional force also moves forward along with the movement. And as you brake, it is opposite of this analogy. So ground is going to try to pull the wheel backward this time when the car is braking. The frictional force is going to point towards opposite of car's initial movement. If, let's say, there is no frictional force, then wheels can spin as fast as they can, and it will still not move the car. So you do need a frictional force to move a car forward. Energy and work theorem. So again, same example, car moving forward. Kinetic energy of this system would be half mv squared plus half iw squared. So half mv squared just talks about a energy where the car moves forward, and half inertia times angular acceleration squared, they are talking about how the energy that wheel is going to use to rotate. Another type of energy, which is not present in this system, it is a potential energy. Force of gravity is equal to mass times gravity, and potential energy is about force of gravity times how high they fall from. So if an object is falling from a sky, they're going to have a high potential energy because they're falling from a very high place, which is going to give h a larger value. In work done, they just talk about a change in energy, final kinetic energy minus initial kinetic energy. Impulse and momentum. So momentum talks about how easy and hard it is to stop a motion. So if a bus is going really, really fast, you know that they have a high momentum because their mass is big and their velocity is big. Opposed to a person simply running, they're going to have a lower mass and lower velocity. So they're going to have a lower momentum. Impulse talks about how the force changes in momentum. As demonstrated in this formula, force applied over a time is equal to change in velocity. So if a big force is applied for a short time, that will have a similar effect as a small force being applied for a longer period of time. Thank you for listening. That is it from me.